Welcome back to another round of thrilling science notes. We're going to be talking about mineral identification in two parts, just because there are, I believe, 7 characteristics we're going to be looking at when we identify minerals in the coming future. So today, part 1, we're going to be talking about color, luster, streak, and hardness. So 4 different characteristics that minerals may possess. Well, they will possess them, just in some form. So, mineralogists, we're off to a good start. These are scientists who study the distribution of minerals, mineral properties, and their uses. They have identified simple tests to help classify unknown minerals. So let's break down all these parts, okay? They study the distribution. Where on Earth are these found? So maybe we only find halite and calcite, salty minerals, near an ocean. That makes total sense. Mineral properties, that's what we're talking about here. Color, luster, streak, hardness, and so on. And their uses. A lot of these have really ritualistic uses. Wiccans, pagans, witches, they believe that these carry special powers. The feeling of love, the feeling of anger, the feeling of protection. I'm sure your grandma has a big pair of gemstone earrings. Okay, so they have all different types of uses out there. And we just need to be aware of how we identify these, because some of them are going to look very similar and some are going to look drastically different from each other. So we're going to start with color. It's the most obvious. Color alone cannot be used to identify minerals. So although this is the first thing you're going to see when I hand you a chunk of sulfur, you're going to see a bright yellow, basically rock in front of you. That's not the safest bet, because sometimes minerals may have the same color. You might find a bunch that are clear, or a couple that are white, or you might have some with various shades of blue or purple. Let's look at olivine and pyroxene here. Both these are green, and you might say, Riddle, yeah, they're totally different greens though. This one's like a way cooler green, and this one's like a gold green. Yeah, I see that. But if I'm walking up to a stranger and I said, hey, I found a mineral, and it's green, that's not a lot to work off of. You've got to give way more specific details. So color is a good first step, but we have to go into more depth. So that's what we're going to keep doing here with our different slides. Sometimes the same mineral can actually be different colors. So quartz, for example. Quartz can be clear, white, smoky gray, purple, orange, or pink. You might even see down here some black or red. These variations indicate chemical impurities. So what that means is while the crystals were forming, hardening, and setting, something went wrong. Okay, think of like a cake. If you let it bake a little too long, then it gets brown, it gets black and burnt. If you accidentally add in the egg yolks into an egg white omelet, all of a sudden you don't have a white omelet anymore. It's the same principle. So something got in here, maybe a little bit of air, maybe a little of another element that caused these different colors. But all of these are quartz, and they all have very different colors. So again, you walk up to that stranger and you say, hey, I found something that's green. And he goes, great, you just found olivine. That was from the last slide. Wrong. So you really have to get more in depth than just color itself. So that's where you add in property number 2, luster. The way a mineral reflects or absorbs light is called its luster. So minerals like copper, silver, gold, they're all very reflective. They're all very shiny is another way to describe this. This produces the shiniest luster, metallic luster. So if you think of something that's metallic, such as a dime, a nickel, a quarter, a silver necklace, those are all metallic. They're very metal looking, silvery. I like the silver Sharpies. It's because it's metallic looking. So this is a chunk of silver. It's a mineral. It's also an element. So it has a very high luster, or it's very shiny. Okay, that's pretty much what you need to understand here with luster. But there's different variations. So on this slide, we're talking about metallic luster. It's very metal looking. Makes perfect sense. Hey, Nuka, I'm recording notes. Yes, sir. Non-metallic minerals have a luster type that might be shiny, but not necessarily reflective. So we have metallic are shiny and reflective. Non-metallic might not be both of those. So a cut and polished diamond has a brilliant luster. Picture a woman's diamond ring, or a young man's diamond earrings, or a diamond necklace. it's very shiny. You can see the light bouncing through it, bouncing off of it, and reflecting back into your eyes. Other words to describe luster include waxy, silky, pearly, and vitreous or glassy. So you're going to kind of have to become familiar with all of these in preparations for the labs in the coming days. So this is a glassy or vitreous luster in quartz. It's called glassy because it literally looks like glass, okay? It's not necessarily shiny. You can see straight through it. It just looks like a window on your car or on your house. Okay, so that's what vitreous or glassy mean. Waxy, silky, pearly, you're going to have to kind of just become familiar with those. Pearly is like a pearl, okay? It's not really see-through. It's kind of still shiny. And then you'll become familiar with waxy and silky as you get some of these into your hands. Minerals sometimes actually don't have any luster, though. So you might have a metallic luster, you might just have a little bit of luster, or you might just be earthy or dull, kind of Luster is directly related to the chemical composition. So right here is a really mean mineral that I don't know how to say it. Silamonate. That's the best I can do. Some of these words are even a little tricky for me. So this is a dull or earthy luster. It's not shiny. It's actually kind of boring. Just looks like a rock or a chunk of coal. That's still important to know, though. Luster is important. It's either shiny or not. That's kind of important. So we do still need to take that into consideration. So if I would give you a chunk of this thing, you would write down earthy or dull, or even no luster is probably fine. Because you just need to be aware that it's not shiny. Now, the next property that we need to be aware of is streak. And no, I'm not talking about your Snapchat streak. So we're talking specifically with minerals. Some minerals, like graphite, produce a powdery residue when scratched. So if you're using a pencil right now, you're using a mineral, graphite. Run your finger across it, and your finger's actually going to feel a little bit slick or smooth. When I was in 8th grade, it was called chemistry and physics, so it was a little different than what you guys are learning now. And we had to make a car, but the only thing we could use as an engine was a mousetrap. Like that spring-loaded thing that you stick the cheese on, and then when the mouse eats the cheese, it no longer lives, that thing. So we had whatever materials we wanted. We have like a month to make it. Well, I figured out that graphite pencils actually lubricated my tires so that they would spin more easily when that mousetrap set off. So I actually used pencil tip shavings as a kind of oil for my tires. So that was pretty cool. So go ahead and try that with your pencil. Your fingers might feel a little bit slick or like powdery. Okay, so that's what's going on there with the streak. Rubbing a mineral over an unglazed porcelain plate, a scratch plate, will sometimes leave a colored streak on the surface. I have a picture of a scratch plate coming up. Streak is the color of a mineral in its powdered form. So when I give you a chunk of mineral, you're looking at it in its solid, rocky state, for lack of a better word. It's not a rock, but for lack of a better word, let's just stick with that. What you're doing when you're taking a streak is you're actually chipping away layers and parts of it, and you're creating a powder. It is still a solid, but sometimes the outside is not the same as an inside. So think of a steak, okay, a nice, medium, beefy steak. The outside of that steak, when they bring it out to you at Texas Roadhouse, is what color? It's brown. But when you cut open that steak on the inside, what color is it? It's pink. So there's a little bit of variation here. So sometimes streak is extremely important because the outside and the inside might not be the same color. Streak can only be used for identifying minerals that are softer than porcelain, and we're going to talk about hardness as our last characteristic. So if you took a chunk of diamond and you tried to scratch it on these plates down here in the bottom corner, it's not going to do anything except scratch your plate. It's actually going to create like a canyon down into the plate because diamond is the hardest thing out there. But anything softer than this porcelain, and you're going to find that out on the next couple slides, will leave behind that powdery residue, and that will allow us to see what color is this mineral truly. Okay, so here's two examples. The streak colors of spectacular hematite, it's over here, or metallic, and earthy hematite. So you can see they're very different color-wise. This one over here is very shiny, high luster. This one over here on the right is dull or earthy. Both of them are hematite, though. Hematite leaves a distinctive reddish-brown streak, whether the sample is metallic or earthy. And you might be looking at me saying, Riddle, dude, these are two totally different colors. They are. But at the same time, they're both kind of red. Okay, they're similar. You can see this one has a little bit of a metallic, shiny quality to it, and this one's a little bit more clay looking. But it's not like one of them turned out green, or blue, or didn't leave a streak at all. So these created similar streaks. So that's where we have to pull together all of these properties. You can't just say, boom, Riddle, I found it, look at that red streak, it's gotta be hematite. Because what if I gave you this one over here? Okay? I would count this one as true brown, whereas this one's red, but you really got to take in all of these properties in order to get the correct identification. So non-metallic minerals will generally produce a white streak. So that's why on the last slide there was a black streak plate and a white streak plate, because sometimes we need to see. Whereas metallic minerals produce a characteristic streak with different colors. Different samples of the same metallic mineral can vary in colors, but have the same streak color. So I'm just kind of saying the same thing again and again here. You need to take into consideration all known information. The color, the luster, the streak, the hardness, all of the other things I'm going to talk about in the next time when we meet together for our notes. You cannot just look at this sample here and say, Riddle, it's a nice brownish black streak, it's gotta be gold. Because you really don't have a lot of evidence to back you up. You need to collect all of the data possible. And the last one we're going to talk about today is hardness. Streak is related to the mineral's composition and hardness. And just like you already know, hardness is the resistance of a mineral to being scratched. It's the exact same thing with anything in life. Okay, if you're wearing a helmet when you're riding a bike, your helmet's very hard. It's hard to scratch your head. Whereas if you go out without a helmet and you wipe out, super easy because your head's really soft. Same thing here, okay? Some foods are very hard. Jolly Ranchers, super hard. Whereas Tootsie Rolls, super soft. It's the exact same thing. So Frederick Mohs, so it's the Mohs scale. He developed the scale to compare the hardness to different minerals. It's a nice and easy scale, 1 through 10. Okay. Number 1 is the softest, and the softest thing out there is talc. Baby powder is actually a mineral, or part of baby powder is mineral. Okay. And then number 10 is the hardest, and that's diamond. And here is our man, Mr. Mohs, excuse me. He looks like he needs to calm down that collar a little bit. So here is his scale. Okay, so hardness. The hardest you can get is 10. Diamond. Then he jumps down to 9. 8. You might have heard of topaz. That's a common necklace or something bracelet you can buy. Quartz, we've mentioned, comes in a variety of colors. Feldspar is all throughout Earth and the soil around you. Apatite, fluorite, that's fluoride for your teeth. Calcite's salty. Gypsum, and behind here is talc, nice and soft. Over here off to the right, what you can see is some common objects. So Mohs actually went in and he found some common household items to kind of use as compare. So he found that glass has a hardness of 5.5. A nail, like one that I would hammer into a board, has a hardness of 4.5. A penny has 3, and a fingernail has 2.5. So we can actually use these 5 common objects to kind of gauge where we are. If your fingernail can scratch it, it's either gypsum or talc. If a steel file can scratch it, then it's one of these, 6 through 5. Okay, so we can kind of use those tools to help us identify things later on. So quartz has a hardness of 7, which means it will scratch anything softer than it. If I took a chunk of quartz and I rubbed it up against some gypsum, the gypsum's going to powder, the quartz is not, because gypsum has a hardness of 2. But it will not scratch anything harder. So if I took this quartz and a piece of diamond, my quartz would get a scratch. My diamond would not. Okay, so you'll kind of catch on to this as you get your hands dirty next week. Mineralogists use ordinary objects to find the hardness of known materials. I kind of already told you this on the last slide. So glass has a hardness of 5.5. So if I scratch something up against glass and it leaves a nick, that means it's at least harder than 5.5. An iron nail is 4.5, your fingernail is 2.5. So therefore, if your nail can scratch it, your thumbnail or fingernail, the mineral in question at least has a hardness of 2.5 or less. So that includes talc or gypsum. So we're really going to dive into this next week. This was just an introduction into all of our different properties. Go ahead back to Google Classroom, figure out where you need to go next, and that should be it for your notes for the day.